I think that a living system must have something which you call metabolism, for example. And the virus doesn't have a metabolism. You cannot demonstrate it. Of course, when the computers in which these viruses work, the computer consumes energy, right? But you cannot say that this piece of energy now has been taken up by the computer virus. It doesn't. You cannot say this really, but you can say that this piece of molecule has been taken up by the cell, and now it's being degraded, and it generates a lot of ATP. ATP is an energetic currency. The adenosine triphosphate is an energetic molecule that is kind of a general currency for energy in living cells. So this is why I say that it's useful to avoid terminological confusion when it comes to applications, to actually make this distinction. And by the same token, real viruses are not alive either, because, you can crystallize viruses, right? And they don't do anything by themselves, right? They disintegrate with time, which is sometimes very good. A virus is essentially a program that says, okay, make several copies of me. So it diverts the resources of the cell. Cell is obviously, by any reasonable standards, the cell is alive by itself. The virus doesn't do anything by itself. And if you use this again from the computer world, you would like to have an analogy, is the virus is analogous to a program that you feed into the computer, saying print me out or reproduce me, copy me, as many times as possible. Even if, for example, you could imagine that the command is to print, and if you do that a lot, suppose that the whole system is shaking a little bit when it's printing, right? There will be a time when the computer might actually become faulty because something is detached, right? But the program will not care for that. It's just like viruses don't care for the well-being of the cell. So the virus is analogous to this selfish program, and the cell is analogous to the computer.